So this is the Docker crash course, or otherwise known as how to set up a Pleb Lightning node for production and development.
Woo! Oh, can't wait.
Emphasis on the development part. So we talked about going to this link earlier. So yeah, just toss that in to your browser if you want to see this link on GitHub in this presentation, and with easily clickable links. So you can follow along. So this presentation is pretty resource heavy, so you can use it as a resource after the presentation is over. So this is kind of the overview that we're going to be going over. What is a Docker container? Setting up a Docker environment, if you guys don't already have one. How to use Docker, because there's a number of different ways to use Docker. You have the command line interface, which is my favorite. You also have this thing called Docker Compose, where you sort of put together a configuration file, and Docker just spins everything up the way that you want it, using a config file. And then there's also this cool service. I don't know if we'll get into it during the presentation, but there's this cool thing called Portainer. Portainer actually runs within Docker, and it is essentially a web server that manages Docker. So one cool thing about Docker is that it has a very extensive API. And if you use that API, you can use it to orchestrate some really cool things in Docker. So what Portainer does is it basically gives you this cool interface, so you can spin up containers, spin them down, like load up config files, basically build like an entire stack of Docker containers to build an application. So Portainer is really cool, allows you to do all that stuff. And we're going to go over how to do a simple template project that we can play around in. And we're also going to launch our own Lightning node. So that'll be fun. We'll all be running Lightning nodes today. Should be pretty cool. And you'll be able to connect to them.
Can we ask questions during the
Absolutely.
Okay.
Yeah, feel free to just bark them out.
Can there be is it common to have multiple containers?
Oh, yes.
Implement an application that
Yes.
add to a single application?
Yes. So typically they're called services. And then within a service, you can have multiple Docker containers that are running. Each Docker container runs its own process. So a process could be a database, or a process could be a web server, or a process could be a proxy, a Tor relay. So all of these different these different processes that you need in order to build what is essentially your service, Docker helps you orchestrate all that. Yeah. So we'll be going over that. So the container is the actual runtime environment. So you have the image, which is essentially, so we'll be going into like essentially what initiates the Docker image, the Dockerfile. So yeah, we'll go over that. Yeah. But the image sort of helps you build the container, the environment essentially. So it is the document that tells Docker how to build your environment. So moving on, so to set up a Docker environment, there's different ways you can go about it. So the easiest way to get Docker up and running and to get your hands on it is just to get Docker Desktop. So Docker Desktop is this application that the Docker company, I guess, whatever they're called, I forget their name, they make this really cool application that works on all platforms, including Linux. It used to be it only worked on Windows and Mac, and it didn't work on Linux. So I just downloaded this recently because I didn't know they even had this available for Linux too. And it's pretty slick. I mean, it allows you to manage all your containers, build containers, download stuff from their app store. It has plugins, extensions. It has everything you could want. So it's actually pretty cool. If you don't like using the interface and you want to do stuff from the command line, then you can skip this and just get the Docker engine. So the Docker engine is essentially what actually runs everything. It's what runs your containers. It's what sets up all the networking between the container, like everything, the API, it's all run through this. So if you install Docker Desktop, you get this running behind the scenes. If you don't want the desktop, you can just get the Docker engine. Optional, you can also get this VS Code extension, which is really cool if you use Visual Studio Code. There's probably, I would think like most other code editors have some sort of Docker extension that you could use. But the VS Code one's pretty cool. It's essentially a mini Docker desktop inside your VS Code that allows you to control your entire Docker environment. It's really cool. And then one optional thing you might want to do on your Docker journey is register on Docker Hub. So Docker Hub is their app store, essentially. So the goal of Docker is to essentially containerize all the things, which is to take these complicated applications that you usually have to set up that just crap files all over your file system that sort of change your operating system in different ways. So all of these like heavy applications you would have to use, like running a database or having to run a firewall or having like to run even like a desktop application. You sort of have to install it on your machine. And when you install something on your machine, there's no guarantee that you can uninstall it cleanly. So one of the cool things about Docker is you can wrap an application so that it essentially doesn't leave any fingerprints on your machine. So everything that application needs to run is inside that container, and then you kind of exchange these containers around like they're apps, and you just spin them up on your machine like it's an app, like it's a desktop app. And then, so containerizing all the things, Docker has this service called Docker Hub, where anybody can host their own containers that they create, and other people can download them from within Docker. So it's really cool. We'll be using it. And you might want to publish some stuff of your own. So that's going to be on Docker Hub. So the anatomy, or no, these are ways to use Docker. So yeah, we kind of went over this real quick. So all of these are helpful links on how to use all of these different things in Docker. If you want to use the command line, like this is the reference for how to use the command line. And you can see it's docker.com/engine. So when you work with the Docker engine itself, you typically work with it through the command line. So everything you need to know about the command line, they have a pretty extensive command line. It's actually really good. So everything you could want to know about the command line is here. Docker build. So that's probably like when you get into building your own images, Docker build is what you use. And we're going to get into Docker files, like Dockerfiles, which is essentially this file that tells Docker how to build your environment. So anything you ever want to know about using Docker build and using Dockerfiles is at that link. Docker compose. So the builder, when you build stuff with a Dockerfile, typically you're only building the environment within that container. There may be other things that you want to set up about the container that doesn't pertain to the environment. It pertains to your environment where you're running Docker. So you might want to expose ports on this container that then connect to other ports on your machine. You might want to do some networking configuration between containers. You might want to maybe put restrictions on how much system resources a particular container can use. Environment variables that are injected into a container. So anything that doesn't have to do with building the environment inside the container, but has to do with stuff about the container itself, that typically you either set that up on the command line, or if you don't want to deal with that because it could be a pain in the ass, they have this thing called a compose file. And it's just like a simple configuration file that allows you to tell Docker, hey, this is how I want to set up my container, or containers. You can actually set up multiple containers, and that's how you then build these stacks of containers that kind of represent like a service or like a real application. And then, of course, Docker Desktop. Docker Desktop is a really slick way to use Docker. It's probably, if you're new to Docker, the best way. and they help you go through all this stuff too, all these steps. The VS Code extension, which we talked about, and then Portainer. If you want to actually install, if you have Docker running and you want to install Portainer, just go to this link down here. And you can actually get Portainer up and running on a port that you can access through a browser, and then you can manage Docker through Portainer as well. That's my preferred way to do it. It's also cool because if you want to set up a Docker server somewhere and you want a nice way to administer that server through a web browser, Portainer is your best friend.
So does Portainer run inside the container, inside your container, or is it its own container?
Well, it's pretty meta. So Docker, you can run this inside of a Docker container. And the interesting thing about Docker is you can actually access the Docker API within a Docker container. So that's what Portainer does. It accesses the Docker API from within its own container and then gives you this whole administrative interface that you can use.
So my question is, the Portainer runs as a container.
It runs within a container, yeah.
It runs within a container outside of your application, right? It's not part of your application, it's outside the application.
Yeah, so you can, you essentially start getting into the Umbrel kind of side of things, where you can use Docker to build like your own Citadel, where you have all of these server applications that you use. And they're all hosted in their own little Docker containers, and they sort of represent this server environment that you access through a web browser. It's not necessarily like a desktop environment, but it's this server living somewhere that hosts all of these applications for you. One of them, and so if you need to manage all those applications, Docker Portainer is a good way to do it. Or you can build something snazzy like Umbrel or Start9. I mean, they're essentially Portainer with a pretty interface. So, yeah. Enough shilling Portainer. So this is the anatomy of a Docker project. And we're gonna, when we get hands-on into a project, then we'll go over this again. So this is just like a quick overview. So in a typical Docker project, you have these things. You have the Dockerfile, which builds your Docker image. And actually, before we get into this, I almost forgot. I kind of want to go over a cool visualization for how to kind of see what Docker is. So is anybody here familiar with virtual machines? You've used VMs in the past? Okay. So yeah, so typically with a VM, you're sort of hosting the bare metal, or you're virtualizing the bare metal. So that's where this like infrastructure comes in. And then on top of that, you have the host operating system. You have this hypervisor on your machine that essentially prevents these, like you can run these virtual environments on top of your hardware, but they don't have access to the host operating system. So it's this nice little firewall that secures your host operating system from any kind of shenanigans you might be getting up to up here. Containers are a little bit different. There's no hypervisor. So you're not simulating a virtual machine when you use a Docker container. A Docker container uses this concept called CH rooting or jailing in Linux. And you're essentially you're creating this environment in your file system where essentially the files that live inside of this file system are jailed. Like they don't know what's outside of their own personal little root of the file system. And so you're still providing your operating system to these applications that are inside containers. They can still see your operating system, but the container engine, which is the software that Docker uses, it essentially jails these applications, so they're restricted to only being able to see certain things, and they can only write, well, they essentially can't write to your operating system. They can't write to anything at all. We actually have to give them a special volume that they can write to, because otherwise everything would be read-only. So the cool thing with Docker is that it's more efficient. Like the overhead on running these containers is far less than if you were simulating like an entire machine. So it's much lighter on resources. and you still get a lot of the security benefits that you get with doing a virtual machine. Docker puts up a pretty strong firewall between stuff that's inside a container and stuff that's your actual operating system. So this is the structure.
So the Docker daemon is the container engine, right?
Yes. And then I wanted to show like another example they have here. So again, it's reiterating that each container does have access to your host operating system, but it's highly restricted. So it can only access resources that it needs in order to essentially run on your machine. So instead of like, with a virtual machine, this would be completely virtualized. Whereas with Docker, it does allow access to low-level stuff in order to like run the containers, but Docker, essentially, the Docker engine is the middleman that sits there and guards everything. So going back to the presentation, Shift F5 should do it.
Are these containers though, they're not a virtual machine, but is it
No.
technically like a virtual operating system? Because you choose an OS, like that everything's gonna run on in it.
So
still using your operating system.
you can run your own operating system software within a Docker container, but like the low-level resources that it needs to access in order to access the hardware on your machine, it's accessing the kernel essentially. It's accessing the same kernel as your host operating system.
Yeah, so in virtualization, there's different types of hypervisors, right? So there's like server data center ones, like I think they're like hypervisor type 0 is when it runs on the bare metal. And that's like what Google Cloud and like Amazon AWS run on. But there's this different type of hypervisor, I think it's type 1 or 2, and that uses your operating system, like the Mac operating system as your underlying resources. And then Docker runtime lives on top of that. And then within that, you have all your containers, which are literally just Linux images with your code running in it, right? Or just a bare Linux image or anything you find on Docker Hub, or your own container repository. But yeah, it's very similar to virtualization. You can mentally think of it as a VM if you want to.
Yeah, conceptually.
But technically it's not, but like mentally just use that mentally.
You can, but you have to be careful because you are running containers on your operating system, and it does, or you're running it on your hardware. So like, for example, there's, like if you don't have an ARM device, like it's difficult to create containers that have an ARM environment because you're not virtualizing the hardware. You're still using the same hardware, and you're using essentially the kernel that allows the operating system to run on top of your hardware. The Docker containers are still using that as well. So you're restricted to like your physical environment. Whereas with like a virtualization, you're literally virtualizing the entire environment. So it's a little more efficient that way, which means that like you can spin up like tons of containers. Like on this crappy laptop that I got at Costco, I've run like dozens and dozens of nodes, and it just runs fantastic. Yeah. So this is the anatomy of a Docker project. We went over the Dockerfile. It's essentially what builds your Docker image. So Docker images are read-only. So I couldn't find a good graphic for it, but another efficiency that Docker has is that containers can share the same image. So like I was talking about, you can spin up like 10 different Lightning nodes. Well, those Lightning nodes essentially use the same operating system, and they use the same software. Your image creates this operating system that they all can share, because if the operating system is read-only, then you're never going to have any conflicts where one node is changing something that the other node is reading. So
Docker desktop is a very visual picture of everything.
it shows all that to you.
Are you doing it in your demo?
I'm going to bring it up, and we're going to go over Docker Desktop. Yeah, I didn't even know they had it for Linux. Like that was like a recent thing.
I think that'll paint the picture for everybody if they physically see Docker desktop running with all the containers.
With all the containers, we'll get there. We'll get there. So yeah, so typically you'll have a Dockerfile. This builds the read portion of your application, which is the operating system and like any of the binaries or anything that you need. And these can be really slim. And you can build, like we were talking about Docker Hub earlier, where you can download applications. You can download applications from Docker Hub from your Dockerfile. So typically you'll see Docker files where they'll download Alpine Linux, so they'll download a slim version of Debian, or they'll download Node.js, like literally an environment with Node.js running, and then you build stuff on top of that. So it's like the combination of Docker files being able to create images and also create on top of other images. You can create these Docker files that are just really powerful, and they don't really use up a lot of space. I mean, like you can create a Docker file that creates a 1 gigabyte Docker image, which is a lot, but if you're running like 10 applications on top of that image, you still only need that 1 gigabyte. You don't need 10 gigabytes. You're not copying this information, so it's very efficient in that regard. You'll see this pattern called entry point .sh, sh standing for a shell script. So Docker containers are typically designed to be a single process, meaning that you're not running like a full stack of applications inside the container. If you need to run multiple applications, then each application should get its own Docker container. And a Docker container should feel like you're spinning up an actual binary. Like you're just essentially, you create the container, you send it a command, and the container spins up some binary or an environment inside, takes your command, runs the command, gives an output, just like a regular program. And yet, it's, how do I rephrase that? So a Docker container typically only has a single process, but sometimes you want to like orchestrate multiple processes inside the container. And so you need some sort of like entry point script to kind of like create this environment inside the container. Because the Docker image just really builds that environment, but it only launches a single process. So you need this entry point script to bootstrap multiple processes if you want to get like pretty crazy with your Docker environments. There's also these shell scripts that you'll sometimes see, one for building. Docker files are pretty limited in their commands, so sometimes you need a little extra functionality, and so you need like a shell script. So you'll see projects that have a build shell script that works with the Docker file to essentially build the Docker image. And same thing, sometimes like container setup scripts can get a little complicated. So if your compose YML isn't able to do the job, then you can use like a start script. So there's a lot of different ways to.
What I'm getting out of this is build.sh and start.sh go with images and the creation of images, whereas compose.yaml, it is basically a configuration file for the container itself that runs as a process.
Right. So the compose YML configures the container. Start.sh would essentially be something that either works with your compose YML or you can use it instead of a compose YML. So like when I use Docker, I don't typically use compose YML, although it's the better way to use it. I just create a script that uses the Docker command line to spin up containers. Because like, again, there's like multiple ways you can use Docker. You can use it from the command line. You can build scripts on top of the command line. Or you can just not use the command line at all, and you can just do Docker files and compose files. And you literally maybe put in one command to like bring the whole thing up, but everything else is just configured from. So you can like ignore this completely and just use these two files. But if you want to do like more fun stuff and more complex stuff, which we'll get into, it helps to kind of have like some scripts that help fill in the gaps where these configuration files can't really pull the weight. So show of hands, like who does not have Docker installed right now? We all have it? OK, perfect. So then we're ready for this next slide. The hello world. So when I tried Docker Desktop on Linux, I've used Docker Desktop on other platforms before, but when I tried it on Linux, put me through a tutorial. And it did this like 101 tutorial where you essentially set up a container, you download some image that they have prepared for you, and it was quite complex. Like their tutorial was like, spin up this environment that has a web server running, and then open your web browser, and then go to this, URL, and then go through this whole tutorial that takes place in the web. It was kind of complicated. I thought this was a better Hello World. So if you have Docker running, you can just type in this command in your terminal. And let's break down what this does. So we use the Docker CLI. We use their run command. So this run command is essentially how you create a container. We're telling it that we want an interactive container with a terminal attached to it. So typically, when you run a container, it runs it in the background. So it just spins up a container in the background, and then you're done. But if we use the interactive command with the terminal command, we can actually attach a terminal to that container after we run it, and we could be inside the container. You can open a port and then on the container at port 80, and then you can attach it to your port 80 on your machine. So traffic that goes to port 80 on your local host actually gets forwarded to the container. So this is how you can sort of run a web server on your computer within a Docker container, and it can still communicate with the outside world. And then this is the name of the image. So if you're launching or you're building an image that is within your own project, you just put a dot here. So like get rid of the node latest and just put a dot, and you'll just reference whatever Dockerfile is inside your project. But the cool thing about Docker Run is you can actually name images that are on Docker Hub. So if you do this pattern, what Docker will do is it'll first see if you have any images saved on your local machine that are under this name. But if it can't find it, then it'll go on Docker Hub and it'll try and find this image. And so this is an image that's maintained by Node.js. So if you run this, you will get Node running in a container right off the bat. To prove that you're running Node, you can just run this simple little program. And you'll see that it runs. So should we do this live? Let's do it live. Let's have a race. See who can get this done first. So Docker run. First, to prove that I even have Docker on my machine, let's see which Docker. So a good way to prove that you have something installed is the which command. So Docker run. This is on Linux. This might be different on other operating systems. And we're not actually going to use a web server just yet, so we're just going to do node latest. We don't need to open any ports. And boom. So I've already ran this previously, so I already downloaded the image. So the image is cached on my machine. So because I already have the image, Docker knew to look this image up on my machine, and then I'm in Node. And this is a node that's inside the container. It does not have any access to my machine outside the container other than what I allow. And yeah, you can do hello world. IT essentially allows us to do this. So if let me close out of this. So if I ran this without IT, yeah, it ran it, and then the container executed, and it saw that there was nothing to do, and then it closed. So we use IT so that we can connect to the container. And then boom, we're inside the container. So we're immediately launched into a Node terminal. So and this is Node. Oh, wow. Oh. Live debugging. There we go. Yeah, so we're within Node.js, just like that. OK, so let's do something a little more sophisticated than that. There we go. So this is a pattern that I like to use. You don't have to use it, but this is a pattern I like to use. I call it the Workbench Pattern. Essentially sets up a project where you're working within a Docker container, just like we were doing with Node.js. Only it's a Docker container that lives, and you constantly configure it, make changes to it. This pattern we're going to get into in a little bit. But yeah, so there's a build folder for when you need to build stuff, a config folder for configurations for your container, a data folder for any persistent data, because Docker containers typically don't have persistent data. You have to give them write access and a place to store data. Your home folder, which is like a place you can personalize your environment inside the container. A cool thing about Docker is that you can write these Docker files that essentially copy a pre-made file system that you have set up on your machine and copies it into the container. So you can essentially really customize your environment inside the container. .env file for environment variables, the Dockerfile itself, and the compose file. So that's the whole Workbench pattern. And these are the links to spin up your own Pleb developer node. So feel free to clone these repositories. It's what we're going to be using in this demo. I have a Workbench set up for Neutrino, which is LND using their neutrino mode in order to connect to the Bitcoin network through this special thing called, what was the name of it? Compact block filters. Is that what it uses? But anyway, it allows you to essentially connect to the Bitcoin network without running a Bitcoin node. Same thing with Core Lightning. They have this cool plugin called Sauron that essentially allows Core Lightning to run off the Blockstream API. So you can use that to spin up a Lightning node in Core Lightning. And then I also made a Workbench just for Bitcoin Core. Same pattern. So which one should we use? Should we go for Neutrino or Sauron? I kind of like Core Lightning better for a demonstration. But I'll put it up to a vote. Show of hands, should we go with LND?
Say Core Lightning.
Core Lightning? Core Lightning it is. OK. So I have this. Here we go. Here's Sauron. And let me. This is going to be hard to put this on the projector and work on this at the same time. So let me see if I can change my display settings. 1 second. Go away. OK. Hopefully this doesn't blow up anything you're doing, Car. I'm about to turn on mirror mode.
Yeah, I see that right there.
You still see it?
Yeah.
OK, perfect. All right. So this is a Workbench pattern for Sauron, which is Core Lightning running the Sauron plugin. But typically with like a Docker project, you will have all the stuff that you need. Typically, like it's a Docker project is just bolted on to another project. So you'll have, like if you go to the Core Lightning GitHub, they'll have their whole project there. And then they'll have some Docker files sprinkled here and there. So you can set up an environment for building, set up an environment for testing. LND does Docker a little better. They have like a separate area in their repository where they help you set up a Docker environment to do testing with LND and to kind of set up like a demo. So This is essentially like we're running a Docker environment, and we're configuring a Docker environment that we can work inside of. So for this, we're just going to go over what our Workbench contains. Also, is everybody able to clone this from GitHub? You having issues?
Question. Usually Docker containers are meant to isolate the project. How does this project interact with the outside environment? Or is it just a demo?
So you still have all the benefits of Docker, where this container is isolated from your machine. But the cool thing about doing something like this is that you can break past the one process limitation inside of a Docker container and actually build an entire environment inside of a Docker container, which I like because sometimes when you have, there's two ways to approach it. You can either approach it where you have this project that has multiple Docker containers, and you have to sort of like spin up all of these Docker containers on your machine, and they're all running in isolated processes. And so for production, maybe that makes more sense. But if you're doing development, it really sucks to have to jump from one container to the other and have to reboot this container and then maybe bring everything down and reorchestrate everything again, especially projects that like require you to spin up multiple Docker containers. Like every time you change one thing in one container, you have to rebuild everything. It's kind of annoying. And so it's like easier if you just have one container and your whole environment is in that one container for development. Not advocating this for production, but for development, it's really fun. It feels frictionless. So
So what you're saying is that this demo is completely isolated from any outside processes.
yeah, you still have the benefits of running everything inside of a Docker container. So it's isolated from your machine. I mean, we're going to open some ports. So we have this port, which is going to be for Lightning peering. And we are also going to be using ngrok to connect to our node. So it does have some connection to the outside world. Has anybody had any issues downloading this from GitHub, or are we all good?
Where are we cloning it? Or what is the command to clone it?
Oh, okay. So let me show you that really quick. So if I were to just create like a y'all can see that, right? So if you go to the project,
This is not in the same terminal window that we were using for the hello world.
you could use the same terminal.
You'll just have to control control C out of the Docker process.
Okay.
Yeah, so if you go to the Workbench project on GitHub, what I typically do is I'll go to code, and they'll give you this just command you can copy. You probably want to do HTTPS.
And then just like git clone, right?
Yeah, and then just git clone. Clone, and then boom. Just like that. Okay, so we're going to dive into it. So we have our build folder where I have some Docker files that, these are Docker files that are used for building things. So this is like a common pattern that you'll see in other projects is when you have to compile something from source, you have to install a lot of packages that you would normally install on your machine, and these packages can just crap stuff all over your machine and be difficult to install. So one cool thing to use Docker for is essentially create these little environments where you have everything you need to compile a project from source. You get the compiled binary, you take the compiled binary, and then you just dispose of the container. And then you're done. Like all the stuff that you had to download, all the stuff, the additional packages and tooling that you had to install, like all of that is just gone from your machine. And if you ever have to go back and compile another version of something, you essentially have this image of what is the build environment for a project. So Docker containers are really useful for building things from source. And in the build folder for this workbench, for Sauron, it's essentially what we use it for. We have a Dockerfile for building core Lightning from source. So this will build core Lightning from source, and we can kind of walk through this real quick. So, boom. So if you're familiar with doing commands in the Linux terminal, then this should look really familiar. You're essentially using a scripting language to set up your environment within the container. So this is what a Dockerfile does. It has these directives like run, workdir, from, and if you go to the link for the documentation on Docker build, you get a really great resource on like what all these directives do. But 90% of the time, you're going to use env to set environment variables. You're going to use run to run commands on the command line. And you're going to use copy to copy stuff from your file system over to Docker, the Docker container, or vice versa. So what this does is we set some environment variables. Oh, at the very start, we download our main environment, which is Debian. I like to use the Slim version. Some other people like to use Alpine. Alpine has some issues, but it's also really small. So if you can get away with using Alpine, you should. But this Slim version of Debian actually is pretty small too. It's only like, I think Alpine's like 50 megabytes and Debian Slim's like a little over 100. For those extra 50 megabytes, you have a lot less headache because you're in a familiar environment. So we're downloading Debian, and then once we have Debian downloaded, create some directories that we need for doing our compiling. And then I just install all the stuff that I need. So this is stuff that I wouldn't want to install on my daily driver, because I'm not going to use a lot of this stuff. But you need it in order to compile Lightning from source, or core Lightning from source. So just within the container, we download all these packages that we need. And we install Poetry, because you need Poetry. You can also sort of like tweak things. Like I had to like tweak this a little bit in order to get Lightning to compile correctly. But another cool thing about using Docker for building stuff is that once you tweak this and you get this to work properly, to where you clone a repository, you clone it into your container, you have this environment that you can use to compile the source code. Once you get all that worked out, you can take this to any machine and run this, and now you can compile stuff from source on any machine, which is pretty cool. So the fact that all of this headache can be contained inside one container or one file, and that it's portable, I think is really cool. So this is using Docker files to build stuff. And this essentially we're just creating an environment so we can compile something. And then where's the magic command? Let's see, Poetry install. OK, configure, make install. If you compile stuff from source, you'll be very familiar with those commands. And then we create a tarball, which is like a zip file. And then we copy it from our build environment to this out folder, which is here. And so this is the binaries that get popped out. You can see it here on the side. Let me know if the text is too small. Yeah.
What is your process for writing the Docker file? Like, how do you iterate when you're like writing it to like troubleshoot, like which command you should put in there?
So for Docker files, it can be tricky because sometimes you don't get to see the error messages that are happening because Docker does kind of provide this abstraction between you and what's going on. So what I like to do is I like to spin up a Docker container, log into it through a terminal, and then just like manually set up the environment. And then once you can kind of figure out like what is the flow of commands that set up your environment without issues, then I start putting them in the Dockerfile. So that's kind of like my approach, especially with the new version of Docker build. Like it just does not tell you when something goes wrong. It just breaks, and it doesn't really tell you why, and it's really hard to diagnose. So yeah, I think like how do you set up your own Dockerfile? I think you essentially have an empty Dockerfile, as empty as you can make it, log into it, and then just manually start running these commands to see if you can find, like build a script that you could put in here. Because as long as you can run it inside the environment, then it will pretty much work fine in a Dockerfile. You do get these extra cool commands like work directory, where you can specify the working directory at that point of the script. So it's kind of like CD to a directory. So you get some handy stuff here. I also have a Dockerfile for Tor here. So this is building Tor for source. And this is where you can kind of get really interesting. So for this core Lightning, I just did this quick and dirty. I'm not actually checking the checksums that they have and the signatures that they have for their, because they have signatures to compare their source code to compiled binary to make sure that, I guess, they didn't get hacked or something. So I'm not doing that here, but you totally could. And this is an example of doing that in Tor. So keys provided by this GitHub page, because Tor doesn't like GitHub. They host the Tor project on their own repository. So this actually will set up a GPG key ring and validate the checksums of the project and compile it and then export the binary. So not only does this build Tor from source, but it also verifies the binaries compiled correctly, which is pretty cool. And again, like once you have all this like spelled out in a Dockerfile, it's portable. You could take this and put it on any machine, and then you can compile Tor from source.
So, so Dockerfiles are typically used to build images, right?
Yes.
In this case, they're actually used to build our compiled source.
Yeah. So you can essentially set up a Docker file so that it builds an image. And then when you run that image, essentially, it spits out the compiled binary. So part of the process of building that environment is compiling this project. So it's just think of it like a script file. A Docker file is like a script file. It's creating this environment that has one purpose, which is to compile this project, wrap it up in a tarball, and spit it out. And then it's done. And then it shuts down. Yeah. So that's all this Dockerfile does. And so we don't need like a compose file. We don't need a bunch of other stuff because you don't need a write store you don't need persistent storage. You don't need to open ports. We're literally just creating an environment, building something. But it's containerized. It's containerized, yeah. So this is super useful. Like, I use this so much to just like compile projects from source, and then it's so easy to just like change the version number so when they come up with a new update, and then you get to do all the things that you're supposed to do, and you don't have to do them manually. Like this just magically just compiles a project from source, checks the checksums, does everything, and then you get a tarball. So that's.
So the tools that you need for the compilation process, like you need to get for getting the repositories clone.
Yeah.
And you need actual compilation tools, right? Because there's the language that you were trying to compile. So if it's Go, you need a Go compiler. If you need, if you're using Java, you need a Java compiler.
Yes.
JDK and all of that. So where in the Docker, where in this process will you be actually creating the Docker layers to give you the environment and the tools for you to be able to build from source?
Yes. So because these two examples are written in C, then you pretty much just start with a Debian environment and you download some tools and then you're there. When you're working with like a Rust project or a Go project, You could write the Dockerfile so that you download Go, you download Rust, you download all the tools that you need. But an easier way to do it is instead of starting from Debian, you can actually, like Go will have their own image where they already have a Go environment pre-installed, ready to go. So then you can just, from that image, do all the stuff you need to do. Saves you a lot of time. Or you can start from like just a bare operating system like Debian and then like literally build the environment for the language and then build the environment for compiling a project. Yeah, so that's all just building stuff.
I feel like related to your question, there's like Dockerfile, right? So like it's really great to look in the resources, see how other people have built their Dockerfiles, because some people they've optimized their project really well, so then you can build off of that. Also, I believe there's like a hierarchy in terms of like what commands you want to go run, like one versus the other. Like there's certain reasons why you want to use exec versus run in this type of file. And then you could also like stack like the runs together. You don't have to do run. You could do run, and then like everything else in like an array, depending if you want to be more specific.
Yeah, so every time you see a run directive here in the Dockerfile, this whole command is run in its own, how do I put this? It's so when these Docker files run, and let's go ahead and run one of these, actually, so I can show you what I'm talking about. So if I wanted to run this, I could say Docker compose.
And then all the packages in one go if you wanted to, or there's certain like commands you could do where you could put everything in an array in practice. But there's like kind of documentation.
So if I run this command, Docker compose build, what it's going to do is it's going to run this compose file here. And so I have this, it's very, very small compose file. Basically, all I'm doing is I'm saying, OK, I'm going to have this saron CLN container. It's going to build off of the local Docker file. That's why I have that dot. So it's going to use this Docker file that's right next to it. We're going to name the image this. Give it a name, give the container a name. Also set a host name for networking. So if you're running multiple containers, you can actually connect them to the same network. And then give them host names so that's all really easy for these containers to network with each other. An env file, because we want to load some environment variables. Init is a complicated subject, but it does allow you to run multiple processes. It essentially uses some process manager that Docker provides you for running multiple processes inside a container in an easier way. We're going to connect to this network that we create. That is, I guess we'll leave it as Bitcoin. And we're going to open this port. And we're also going to restart. So if the container crashes, it'll restart automatically. TTY, that's the terminal. So we want a terminal to be running on this container. So when we connect to it, we can connect to the terminal. And these are the volumes that we're going to set up for our container. So we're going to set up a config volume that's read-only. We're going to set up a data volume that's going to be read-write. And we're going to, this is another cool thing you can do with Docker, is that when you host these volumes inside the container, so you are partitioning some space on your machine, and you're giving it to the Docker container so the Docker container can save stuff to it and use it as either read from it or use it as a persistent store. So it's kind of like you're linking things into the container. And we're going to link our config folder so that it's also a config folder in the container at the same location. And for the data folder, we're actually going to link it to the main folder for Core Lightning. So Core Lightning typically saves all its data under your user account /.lightning. And we can actually just link our data folder directly to that. So inside the container, Core Lightning does not know what we're doing. Like, we don't have to go to Core Lightning and say, hey, this is where our data folder is located. Core Lightning can just use everything by default. It can save all of its information here by default. And Core Lightning does not know that behind the scenes, we actually linked this to this data volume. So we do two things. We are creating a persistent data store with read-write access, and we're pinning it right here where Core Lightning likes to save stuff. So you can actually control what parts of your container environment is persistent and what parts are not persistent. And you can do that without having to configure any of the applications inside the container. They can just be completely naive to what you're doing, which is kind of cool because then when Core Lightning puts log files in the log folder and just kind of puts other files everywhere, those files exist inside the container, but once the container shuts down, all those files are gone, except for the ones that we choose to persist. So you get like really nice control over what parts of your file system should persist and what parts of your file system can just die and disappear when you shut down the container. So
in this case, volumes, the first line starts with ./config, right? That just means that ./config colon config and so on.
yeah, so the colon splits between what is the local location of the file or folder, and then what is the location inside the container.
So the local location is the Workbench root folder.
Yeah, so you see this dot here. So yeah, it's local to our project folder, and then we're saying the config path is linked to the config path inside the container. Now this is at root. So with Linux file systems, if the root user has this like root folder, it's like the home folder for the root user. But yeah, so root.lightning is essentially going to be where Core Lightning is going to store all that info. So that's how we have our container setup. So that's our container setup. And then our Dockerfile is just installing some dependencies for Core Lightning and some cool things. Like, I mean, you get to customize your environment. So like, I like to use NeoVim. So I like to add NeoVim to my environment. I like to use QR encode to print QR codes, and we're going to use that. So I like to add that. Tmux is fun for like doing multiple terminal sessions. So I added that to my environment. So we'll go over this and the stuff that it does, but I just want to like actually get this up and running. So to get this whole thing up and running, you just open a terminal inside this project. So is everyone here? Do we have the project downloaded and terminals ready to go? OK. So yeah, just run docker compose build. And let's see the magic happen. Oh, wait, it's not build. It's up build. So we're spinning up the container. Yeah, and so what you'll see is you'll see all of these steps in your Docker file. So one cool thing about Docker files is that every time you use the run command, everything that comes after a run command is isolated within that particular point in the setup process. So that could be a good thing and a bad thing. The bad thing is that if you naively create an environment variable here and then think you can call it here on the next line, you won't. So all of these commands are isolated from each other. So you just kind of have to be aware from that. Every time you use the run command, like you're sort of like a little slice of the setup process of your container, but they're all isolated from each other. The reason why they do that is because if you see where it says cached, so the cool thing about the Docker files doing it this way is that let's say we go through this and all this stuff installs. We do apt-get update, apt-get install. We install all this stuff, that goes fine. And we install Node, that goes fine. And then we have this like curl to download the script for downloading ngrok, and then this fails. Let's say that fails. It's like, oh crap. Well, now we have to start over, right? So you go into the script, maybe you accidentally like put 2 dots or you screwed up the URL somehow, and you fix it, and it's fixed. Then you go, okay, let's build again. So you run this whole build thing again. All of this will automatically, like magically just get put into place where you don't have to do any of these steps again. So every time you use the run command, you're essentially caching that part of the installation step so that if something later down the line fails and you go to build again, you essentially just go right back where you left off. You don't have to re-download all this stuff. You don't have to rerun all of these steps. You just start from the last point of failure. So that's really helpful, especially when you get down, like especially for like the Docker files when you compile stuff, when you like get all the way down to you get the configure working, you get the make working, and then make install fails. It's like, whole crap, it took me 30 minutes to get to that point. I don't want to have to do all that again. So caching is really powerful in that very intensive steps that require downloading a lot of files or compiling a lot of stuff. Like you can do it, it's done, it works, it gets cached, and then if something fails later down the line in your setup process, it's very easy to jump back to that point. So
if you didn't want to include the build steps in this command here, and you just want to spin the container,
yes.
you don't have to do the build. What would change?
What would change? You'd pretty much just go back to our Hello World project, where we don't even reference a local Docker file. We just say, hey, we're just downloading this Docker image from NodeHub or from Docker Hub called Node, and we just download that and we run it, and then we're in a Node environment. Yeah.
But once you run this, so you ran the Docker compose, and then it completed.
It completed. Yeah, we're actually running a Lightning node right now. We'll get to that point.
But once you, now that you got it running, the next time you need to spin this up, do you need the dash print at the end again?
So no. So once you build the image, you don't have to build it again unless you change something. If you change something, then you want to build it again. So yes.
Having issues running this, for one, for anyone who's stuck, you need to rename your env.sample.
Oh yes, yes. We'll get to that.
Also, I don't have my out directory inside of build. So do I need to run like a setup script before I run the initial Docker compose up build? Because when I do run up build, I'm getting a consistent error for lib64, LD Linux, no such file or directory. So it seems like there's some dependencies missing.
So the build folder, there's a couple questions.
Sorry.
So for the env file, let me show you what this looks like. So yeah, so for the env file, by the way, don't steal my token. This is the sample environment file where I just kind of put in my own configurations. And I renamed it from sample env. So here's the sample. And then you just take out the sample and rename it to .env. So you just take the sample env file and then you rename it to .env. And then it should work. So we'll get into like using ngrok with this. You can also just use Tor by doing Tor enabled. I'm calling that.
After we rename it .env, go ahead and do the Docker compose build.
Yeah, but so then Austin, you're talking about another issue you're having, which was this complaining that this out folder isn't here.
It's not complaining about the out folder directly, but I just noticed that I don't have it. And I'm getting an error when I run up build. So I assume.
Does it kill the whole process?
No, it just keeps looping through the error again and again.
Oh, well, you should be able to just create this folder. You don't have to have any of this stuff in here.
Okay.
So just to also kind of go over some other parts of this project. The build folder helps me build binaries. And then I had another project called RegTest Workbench, which would basically use these Docker files to build these binaries and then would automatically copy these binaries into the image. But it's better to have this as a manual step. So you can ignore the build folder, really, because I think when you download this project from GitHub, you already have the binaries in here. Yeah, so Lightning CLI is already in here. Lightning D is already in here. So all the binaries are already installed. So you don't need to build anything. If you clone this from GitHub, you shouldn't have to build anything. But if it is complaining that this folder isn't here, that is a bug. You should be able to fix it by just creating the folder. And then that should fix it. If not, let me know. But yeah, so this project, we have our compose file, which sets up our container, our Dockerfile, which basically sets up our image, our env file, which is where we put some environment variables that we can use inside the container. We also have a config file folder that will take some of these config files that we need to set up certain processes inside the container, and these get copied over, or these get made available to the container. We also have the image folder. Essentially, this is our file system. So if you look in the image folder, our file system is this, which is a lot less complicated than your typical Linux file system because a lot of stuff is missing. So this gets copied over whenever you build your image, and we just have the binaries for Core Lightning, and that's pretty much it. Like binaries for Core Lightning. I think the binaries for Tor are in here somewhere too. Are they in here? Yeah, there it is. So yeah, so we just have Core Lightning in here, Tor in here, and then our home folder, which we're going to get into, where we can like essentially customize our environment. Put our own custom binaries in there, our own start scripts, and this will help like set up a really fun environment for us to work in. So next step is to actually get all this running. So I kind of went over this earlier, where we ran this Docker compose up build. So if you go ahead and run that, you should see this. You should see your Lightning node humming in the terminal. Yeah, this is where the difference between virtualization and containerization really shines, because it does sort of depend on your host environment whether you're able to run these containers effortlessly. So there's a problem that Austin is having where I think it might be the math library, or there's some other library that is in the host operating system that is not, or that is running differently on the Mac hardware versus my hardware over here. So Austin's looking into that issue. But for everyone else, are we at this part here where we see this on our screen? Okay. So the cool thing with Sauron Workbench is that, so you have a Lightning node running here. This is core Lightning. This is actually a script that's running to set up Lightning with some really cool plugins. So one of them is this plugin called Sparko. And Sparko it was originally a Lightning wallet that Fiat Jaff rewrote in Go and turned into a Lightning plugin. And so what that plugin does is it gives you a wallet, and it also gives you access to your Lightning node through like a remote interface. So if we click on this link here, 009737, which is running on our local machine, we should be asked to sign in. So is everyone else getting this? When you click on that link, are you able to, do you get this prompt to sign in? And if you would like to sign in, you can kind of see it here in the terminal output that this is the username and the password. And this is randomly generated and then stored in our data folder, I think under Sparko keys. Yeah, Sparko login. So we can actually log into this if we wanted to. So it's user, and then this password, and then boom. So now we have a wallet connected to our Lightning node, which you can use to pay and request stuff. Now this is connected to testnet, but you can easily reconfigure this to connect to mainnet. And then you have your own Lightning node with your own wallet. So that's not the only thing that you can do with this. Yeah, there's this weird bug with Sparko where it shows that you're having these errors, but really it's working just fine. So the next thing we're going to do is we're going to run this in detached mode. So I'm going to go ahead and stop this. So I just killed my Lightning node. And we're going to run this command again, docker compose up build. Only this time I'm going to add the D flag for detached mode. So what this will do is instead of running this and setting up the container and then connecting to the container, it's just going to run it in the background. So it's going to go ahead and build, run, and then it started. And that's it. So now it's running in the background.
So there's no Bitcoin node running? Where does it, how does it work?
So it's connecting to the Blockstream API.
Oh, okay. So they have like a node running somewhere and you connect to it?
Yeah, whatever node they're using for their Blockstream API.
Is that Neutrino? Is that what Neutrino does?
No, Neutrino uses this thing called compact block filters, I think is what that they're using. But they're sort of like an SPV node.
Oh.
So you're relying on other nodes to tell you stuff about the blockchain. Yeah, that's Neutrino. It's an SPV node. Sauron is actually accessing the Blockstream API. So it's making API calls.
Why is it also not an SPV node?
Huh?
Why is Sauron not an SPV node?
Because an SPV node actually communicates with other Bitcoin nodes over TCP, whereas Sauron is connecting to the Sauron or the Blockstream API using HTTP requests. Yeah, so it's a bit different. So my Lightning node is running in the background. There's another command that is really cool. So if you are running a container in the background, there's this command called docker exec. And what docker exec does is it allows you to run commands inside any of your containers. So with docker exec, we're we're going to go ahead and we're going to launch a terminal inside our container just using Docker exec. So we're going to do Docker exec. Because we're launching a terminal, we're going to use IT because we want to have an interactive terminal with our container. We need to give it a container name, which is why this becomes useful, that we have a name for our container. So Sauron CLN is the name of our container. So we're going to put in Sauron CLN. So we're going to execute a command in our container. And we want it to be interactive, so we want to connect to terminal and see what the output's going to be. And we're going to do bash. So we're just going to essentially run a bash terminal inside our container. And this is what it looks like. So we get this really cool display of network connections. So you can see that I have ngrok running in the background because I configured ngrok for this container. I got Sparko running in the background, listening on this port. And then Lightning, of course, is listening on this port here, which is the peering port for testnet. I got some tmux sessions, so I can kind of, if you're familiar with tmux, you can connect to this, and you can actually see the output for ngrok itself, because ngrok is also running, which I think is tmux a attach. Ngrok, will that do it? How do you attach? I forget. Yeah, so you can use tmux, and also like spits out this wallet configuration. So this is a link to that same wallet that we have hosted with this username and password. Only because I configured ngrok for this container, you can actually connect to it from the outside web. So that's the same wallet, but we're connecting to it over the internet. So yeah, so your node is available, and it can talk to other nodes. So we have that going on. What else can we do here? So yeah, this cool display. So all of this is from this home folder. So the cool thing about doing this like Docker Workbench pattern is you're not just downloading a Docker container, spinning it up, having it run a command, and then it's done, or it's just running in the background. You're actually using it to set up your development environment. So you have the compose file to set up your container, the Dockerfile to set up the environment, which is why I have like QR encode, tmux, all this other stuff. I'm setting up my environment that I want to work in. And then once I have that set up, then where'd my terminal go? You can start to do some of the fun stuff that you can do with Linux, which is in your home folder here, you can actually set up this thing called profile, which allows me to kind of create like custom commands that I can use inside my environment. So one common pattern that you see is that you shorten Lightning CLI to just LCLI. So now I can just say LCLI list peers. Wait, I'm not in my container. Hold on. There it is. So I can clear this. LCLI list peers. I'm not connected to anybody right now. But instead of having to do Lightning CLI and then network equal, I don't have to do any of that because I configured my environment to have this just really handy shortcut. I also have listen, so you can see what sockets are listening on your container. Easy way to get to the log file. So if I want to look at the core Lightning log file, I can just write debug, and it'll just pop me right into the log file for core Lightning. What else can we do in here? Oh, yes. The QR codes and Spark QR. So I configured this so that if we write Spark QR, it'll actually print out a QR code. And this is a QR code formatted for this thing called Spark Connect. And Spark Connect is supported by Zeus. So two things are going on here. One, we have this configured in a way that Zeus will understand, or other wallets that support Spark Connect will understand. And two, we also have it set up to use our ngrok And we'll get into using ngrok. But yeah, so I can scan this.
This is Lightning invoice.
No, this is a QR code to connect to your node. I use it to connect to Zeus. But yeah, it's like an option on Zeus to connect using a scan Spark QR.
And it connects via ClearNet?
Well, I have it configured for ngrok, so it connects over ngrok. If you enable Tor, then you'll see a Tor address here, and it'll connect over Tor. So save this. I understand. Save node config. Yeah. So oh, they updated Zeus. It's pretty snazzy now. Yeah. So I'm connected to my core Lightning node. Yeah. I have a 0 balance. It's really sad. I should probably send myself some sats so I can have some money. But yeah, and then so there's that going on. And then if I just log back in to my environment again. So this whole printout, this is coming from this little init file. So I have it configured to sort of display all this useful information. And all I'm really doing is I'm setting up a Linux environment. So Linux allows you to do this stuff. It allows you to set up aliases, allows you to kind of like set up these cool little displays that you see when you log in. Like you can do this in any typical Linux environment. And because we're using a Linux environment in our Docker container, and we're logging into it, and we're playing around with it, we can kind of like set up our own build environment. And we could set up our own runtime environment for core Lightning. So like you can manage your core Lightning node in here. So like we can say, what was it, lcli, like we did get info. Yeah, so this is all the info about your node. So if you want to use this for a project, like you can basically develop on top of this. You can connect. Yeah, great for hackathons. Great for building.
If I wanted to have this Lightning node, be part of the mainnet and not the testnet, where will changes need to be?
So for Ellen, so Neutrino and Sauron kind of have the same caveat where you have to switch between networks, like between testnet and mainnet. So for Sauron, what you would change, let's just do it right now. So we have this .env file right here. So we would have to uncomment this, and we'd have to change this to main, I think. You have to call it main. Let's see. We're going to do this live. So we're going to change that to main. We're going to run Docker Compose up again. And Docker Compose is great because like if you're already running the container in the background, you don't have to shut it down. You just rerun Docker Compose, and it cleanly will shut down the previous container and then spin up a new container. And let's see. So unknown network name main. OK, so it's not main. It must be.
What do you expect to happen differently from when it is set to testnet?
So let's dive into that.
Okay.
So when we run this, the Docker Compose file composes our container. And then when our container runs an image, it runs an image that has been created with this Dockerfile. And what this Dockerfile does at the very end is it runs this entry point script. So create the container, load the image, and then once the image is done loading, we run this entry point script. So then let's jump over to what the entry point script does. So this is like this is typically what you would use an entry point script for. Like once the container is loaded, once the image is loaded, then the entry point script runs. And so here we have this. This is bash scripting, by the way. That's the language. So here we're just checking that if the network variable is not set, then we just set it to a default of testnet. So this is pretty much being passed into the parameters for starting Core Lightning. So Core Lightning, you specify config file, you specify a network, and then there's some additional parameters that you can specify. So I specify some stuff for the Sparko thing, so that Core Lightning spins up with Sparko configured. So when we change this, when we change that network variable, it changes this. So I believe this has to be mainnet, but it could also be Bitcoin. Like LND has different names for different networks. It's kind of silly. There's really no consensus on this. So I think that if I go back and I change this to mainnet, let's try mainnet. If that doesn't work, we'll try Bitcoin. One of those will work.
But again, you said this connects to Sauron connects to Blockstream APIs, right?
Yeah, but we're using Core Lightning. So, okay, so mainnet is not it. Must be Bitcoin. Change this to Bitcoin. Hold on, let me double check this error too, because there's actually two things that you have to change. So for Sauron, you have to, well, first you have to change the network that Core Lightning is using. So that's what we're changing here. But then in the config file, there is the API endpoint. And so for Blockstream, when you're using the testnet version of their API, they have this little testnet here. So if we're going to connect to mainnet, we actually have to get rid of that. And so now we'll connect to their mainnet API. And so with that change, and it should be Bitcoin network, it should be the right one Core Lightning wants to see. And yeah, so now when we load this, looks happy. It's complaining about the TLS certificate, but that's fine. But otherwise, it looks happy. So now that this is running, should be. Let's find out. So we're going to connect to our container. You can also just like run your container in one tab or one terminal and then connect to it from another terminal. So Docker exec it Sauron CLN, and we're going to do bash. Now we're connected. Right on. So this is our host. Let's do, well, actually, yeah, let's just use this. Open that up. Close that. And we're going to log back in here. So this should be running on mainnet. Let's go ahead and see if I can get some money. 100 sats. All right, this is bits. Want sats. 100 sats. Not that many sats. Description. This is a test. Please ignore. Okay. See if it works. Oh yeah, I'm not connected to any channels. All right. We can do that right now. Does anybody have a channel that they recommend that we can connect to? There's some talk about implementing zero conf channels. I think LND may have implemented it. I don't know about Core Lightning. I don't know if they've implemented it yet. You can configure how many confirmations you want on a channel. Typically, it's, from what I remember, it's 3. You need 3 confirmations. And you can shorten that down to 1, and I don't know if they've allowed you to do 0 yet. But yeah, it's something that should be possible. Like, there's really no technical reason why you can't.
So you are able to launch a production Lightning node connected to the mainnet, right?
Yeah.
So why wasn't this Lightning client, why wasn't it able to find your node?
Because I still have to connect to another peer. Like I'm connected, I'm using you use Sauron to connect to the Bitcoin network. So I'm able, my node's able to see the Bitcoin blockchain through the Blockstream API. But now to use the Lightning network, I still need to connect to another peer and open a channel with that peer. Yeah. So we could do that. Do you guys want to do that right now? Do you want to like go through like opening a channel and because I do have a channel that I can open and then use it to send some sats.
But shouldn't this client open a channel with you automatically?
No.
The process of sending a payment, what I think assumed is that a channel will be set up as part of the sending of the payment.
Sending of the payment. No.
That's not how it
Yeah,
works.
there's no inbound channels, right?
Yeah. Yeah. We don't. We just spun up a naked Lightning node with no channels. So we do have to set up a channel. That's true. We could send an on-chain payment. Should we try that?
Yeah, I think so. Well, now. Give it away,
LCLI. Yeah, so here we just, we can get an address.
That was cool.
What do you just say about maybe testnet is better?
Yeah, testnet, it's a lot easier to send money around.
What do you say about
What was it? I think it was like get address or new address.
Yeah, he can he knows way more than I do. He's asking questions about the inbound. Like, what's the difference between inbound and outbound channels?
So it depends on, it just basically specifies like where the liquidity is in the channel, on what side of the channel is it
When you
on.
opened a node now, it had no facts on it.
Yeah.
Zero facts
Yeah.
or facts, right? But if you had, had some money in your wallet, in your Lightning node that you just spun up, if you had some money in it,
Yes.
then would that have helped with him being able to?
No, because I still have to open up a channel.
I don't-
Still have to open up a
sorry,
channel.
I don't get that concept. Maybe I just need to go back and read it.
Yeah, so with Lightning, so if I want to pay Car and you're connected to Car and I'm connected to you, the Lightning network allows me to pay Car through you. So depending on who you connect to, like if you connect to a well-connected person, then you can just connect to one other Lightning node, open a channel with them, and then you have access to like this whole payment network through that one node. But you still have to connect to at least one node. Yeah, you need some entry point into the Lightning network. So
Yeah, there's no difference between there's only a channel, there's no inbound or outbound channel. People just, it depends where the liquidity is, where, when you open, if I open a channel to you, then all the liquidity is on my side. So you can't send me payments yet, but only I can send you payments, or I can send through you if you're connected to everybody else.
new adder, that's what it is.
Opens the link, the entity that opens the payment is the one that is able to send payments.
Yeah, I don't know if they've implemented yet, but they're doing like dual funded channels where you can do it, so there's like half and half on both sides. But like right now, it kind of sucks because when you open the channel, all the liquidity is on your side. So in order to be able to accept payments, you gotta either loop out, they call it, where you use a service where it sends it on chain somewhere, like half of the payment normally somebody does, or you can just send it to your wallet or Satoshi or something, your other like wallet, so that you have something that people can send you payments. So you always gotta keep balancing it too, because like if you set the fees too low, people will just like fail.
That could be a whole workshop, dude. The inbound liquidity.
They'll use up all your inbound liquidity.
So show of hands if you have a Lightning node up and running right now through this. So we could set up a network here with each other. We can connect to each other. And I have some testnet money, so I can forward some testnet coins that we can pay each other. That'd be kind of cool. Huh? Yeah. Do you? Yeah, we can like just play around with it.
I need help. Do you want to stop this, or do you want to keep going?
I guess like we'll conclude this here. So we have we do have a Lightning node up and running. We can go over ngrok real quick. Does anybody want to go over ngrok? Yeah. So ngrok is just like a really cool tool for being able to connect some service running on your computer and connect it to the outside web and give it an IP address. So what we'll do is we'll just like kind of go over like setting up an ngrok account, because you do need to set up an account for ngrok, but it is completely worth it. So if you go to ngrok and you sign up for their service, what they will do is they'll give you an API key. And that API key is essentially what you need to put inside your env file if you wanted to use ngrok. So for the Sauron workbench, we have a .env file in the root of the project. And all you have to do for your env file is just uncomment these lines, so ngrok enabled equals 1, and then put the API token that they give you here. And that's essentially all that you need. Once you do that, then the rest of the script will take these parameters and they will start up ngrok for you, and they will get the unique URL that ngrok gives you, because ngrok generates a random URL. It'll take that URL and it will set it up so that your Lightning node is available through that URL. So it kind of puts your Lightning node out there on the World Wide Web, which is what you need if you want to actually connect to other nodes and open a channel. You need to be publicly reachable. So you could use Tor to do that. Tor is one way of doing that. ngrok is another way that is much faster than Tor.
Just detailed, follow-up question to that. So if I use the API token to talk to ngrok and get a random, URL assigned to me.
Yes.
As a build script, I'm talking to ngrok using the API key, I get a URL assigned on the fly. Now, what is the process of binding that to the application? How does that happen? If I was writing an application standalone, outside of any of what we spoke about today, writing a plain Linux script or a plain Java program, and I just wanted to use ngrok API, key to get the URL, what's the process of binding it to my application?
So the easiest way to do it is to use their, so ngrok has like a little client that you can download, and that client connects to their API, and that's what you would use. That's what I use. There might be another way to do it, but the way that I do it, you can see in the ngrok init right here, is, well, backtracking a little bit. If you go to my Dockerfile, I download and install ngrok. So this is how you install ngrok officially. You download their signing key. You download or you put this entry in your repository for their repo, and then you can just install ngrok like this. Yeah. So the Dockerfile sets this up for you so that you have the ngrok binary on your machine. And then once that's done, then when the ngrok init script rolls around, because you have ngrok enabled, then what it does is it configures ngrok to add this token, and then it opens a new tmux session, so you can, if you ever wanted to peek at what ngrok is doing, you could. But it runs ngrok, and it runs this command, which it's linking to your Spark port here. So the Sparko plugin, it's the plugin that you use to access your wallet and everything. It's connecting to this. You could change this to connect to your to use your Lightning node port. your peering port for your Lightning node if you want, but Lightning nodes, like as long as you have another Lightning node that you can connect to, you don't need to use ngrok. Typically, you don't need to use ngrok for that. Ngrok is only a problem when you want to connect to your node. So like your node doesn't have any problem connecting to other nodes. It's when other people want to connect to you. So with the Lightning Network, there's a lot of nodes you can connect to that they're publicly facing nodes, so it's easy to connect to them. You don't really need ngrok for that. But if you want to connect a wallet to your node, or if you want to connect an application to your node, and you want to like develop like a website that uses your node to provide a service, now your node needs to be available. And that's where ngrok really shines. You can also do both. Like you can use ngrok to make your peering port available and make like your whatever port you're using, like Spark port for Sparko. But the free version of ngrok only lets you use one instance at a time. So if you pay for it and you get more features from them, then you can sort of just like expose all the things, like expose as many ports as you like. But with the free version, you only get one. So the best way to use that one free ticket that you get is to just expose your RPC port, application port, whatever port you want to use to communicate with your node directly. So that's what this is doing here. Oh, and then this final thing is useful, where you can basically, this is the API that ngrok makes available. Because ngrok also runs like a little web server that provides this API that you can access. And so as you can see, localhost 4040 is typically where ngrok hosts this little web server for their API. And you can query it to get whatever the random public URL it gives you. So you can take that and then you can use it. And what I do is I use it to set this variable Spark host so that when I create the QR code, the ngrok URL is automatically in there.
That's exactly where that was coming from. The question was, how do you capture that random URL that is assigned to ngrok by you? How do you capture it and bind it to your application?
It's this line right here. Once you have ngrok configured with your token and running, you just run this command and you get it. And then you can use it. So tmux is really cool for doing like multiple terminals. So like, I don't use it enough to remember all the commands, but if you look up tmux, it essentially you can run processes in the background. You can create like a terminal session, then detach from it, but it's still running, and then reattach to it. You can run multiple terminals in the same screen. You can do all sorts of cool stuff with that. I use tmux for this project because
Like this command right here, tmux.
right. So since Docker containers typically are designed to only run one process at a time, you don't get any process management in a Docker container. And typically even when you set up a Docker image using like Debian or Alpine or some other Linux distribution, the whole like system process management is usually gutted. So like when they say like this is a slim version of Debian, they like rip everything out. Like you just have the bare minimum that you need to run an operating system. So you don't get process management. So you actually have to install that, which is why there's like a couple things in here that I install just so I have process management. Proc CPS, like you have to, this is the package that gives you like some like psaux and kill and those commands. Like you actually have to install those because they don't come with this slim version of Debian by default. They don't come with Alpine by default, I don't think. So you have to install them. And then when you don't have process management, you can go through this convoluted method of reinstalling like systemd and what you would use as a process manager. But it's kind of like complicated and you have to do a lot of hack read to get it to work. Whereas with tmux, you pretty much just, anytime you like launch a process, you can just launch it in its own tmux session and detach from it, and you can use tmux as a process manager. So that's essentially what I do, is I use tmux as a process manager, so that when I'm running Is this still running? Hold on. So Docker exec IT. So let's see if this is still running. Yep, still running. So because I ran this ngrok command, and in the ngrok command, the process needs to continue running because ngrok needs to run the web server and then make the URL it generates available. So it has to run. Tmux allows you to run it and then detach from it so it's running in the background. And then you can jump back to it. So I forget the command off the top of my head because I haven't used Tmux in a while. But there's a command that you can just attach to this, and then you're essentially in the process, the ngrok processes, and you can see its output and everything. So it's just really handy, lightweight process manager. It's really fun to use. So that's that. Yeah, so I guess we can end it there, but I would like to set up a Lightning node and connect with someone else here. And we can send sats back and forth. I'll give you some free testnet sats if you want some. Testnet is a shitcoin at this point.
All right.
Yeah.
Thanks, Topher. I appreciate it.
Also got my ASIC in my box.
Yeah. All right. So I have, this is me. This is my URL. Does anybody else have this running with ngrok yet? Or with Tor? And we'll see if we can connect to each other. Or see if you can connect to me. So let me see if I can blow this up. Oops, whoa. So that's my address. Make it bigger. How big can we go? Shoot, now I can't even. Hold up. There we go. So if somebody can give me their ngrok URL, I will connect to your Lightning node, and I will send you some sats. Or at least we'll try it. Yeah, because if I open the channel, I have to pay the fees, so I can handle all the fees. No, we're good. All right. And cut.